Hello, and welcome to today's Blaze Meter webinar. My name's Naomi, and I'm delighted to introduce you to our special guest who's presenting today, Mirco Hering. He's going to be covering the topic of how to overcome the 7 sins of test automation. Just to give you a few announcements before we get started, today's webinar is being recorded, and we will send over the recording within the next day to all attendees and to all non-attendees. We're going to have questions at the end of the webinar, so if you have any questions, feel free to put them into the questions box, and our presenters will deal with them at the end. And I'm also going to ask you at the end of the webinar to take 2 minutes of your time to fill in a short survey for us, because your feedback is really important. Okay, Mirco, I'm going to pass over to you and your team to introduce yourselves and to run the webinar.
Perfect. Thank you, Emma. Thanks, everyone, for joining us today to this webinar. So we will talk about how to overcome the 7 sins of test automation. But before we do that, let's quickly talk about who's actually going to present. So my name is Mirco Hering. I'm looking after Accenture's DevOps, Agile, and Test Automation practice in Asia Pacific. I am an avid blogger, so a lot of the content that we'll cover today you would also find in articles about on my blog. And recently wrote a book, DevOps for the Modern Enterprise, that also covers test automation to some degree. I'm absolutely delighted to have one of my test automation architects here with me to co-present, and I will let him introduce himself.
Thanks, Mirco. Thanks, Emma, for the introduction. Hi, everyone. Good morning and good afternoon, based on whichever location you are in. My name is Bidya Chakraborty, and I am with Accenture, looking after the test automation practice. And yes, so today's session is basically based on the learnings that we have had and the implementations that we have done at multiple places. And I think I'll hand it over to Mirco to basically start that.
Yeah, thank you, Bidya. Yeah, so guys, one thing to notice is this webinar is really going to be about our real life experiences. So some of the stuff might not be pretty and pristine. It will be real life experience and the scars that we've taken away. And Bidya and myself have been on a couple of projects together, so we have some shared war stories to talk to you guys about. What we will do, just to quickly cover the agenda, we make it easy for ourselves, so we pretty much halved it. So I have the first 4 modules I'm going to talk through, and then Bidya is going to take the second half. Before we go into the 7 sins, and the 7 sins are really what we see as the 7 most common anti-patterns in test automation that make those projects fail. But before we do that, I want to spend a little bit of time on motivating why I think this is important and why we chose this topic to discuss with you guys. So let's get into it. Test automation is one of the most important practices we have, and sometimes the view is that if you only write the right software, you don't need to do testing. And I was speaking to a client recently that said, "Oh, Mirco, all this testing is great, but we decided we're just going to write good software, and we don't really have to worry about testing anymore." And reality is, and this is a nice little comic from KXCD, if you follow that, it shows you really that the realities are unfortunately different. Right? There are very few organizations, if any, that can really do this. When we look around and we look at the different test automation initiatives, so I have the pleasure of working with lots of different clients across Asia Pacific. Test automation is the one area that we see the highest failure rates, really, when we think about DevOps adoption and different DevOps practices. And that motivated me a few years ago to expand my practice. It was just focused on DevOps and Agile to include test automation as well. And Bidya was one of the first guys that I hired to help me solve that problem. So we clearly have made a lot of progress, and well, we're here to share some of our experiences with you guys. If you look at what the state of the art is, in preparation for this webinar, I did a bit of research. I found one survey that I found quite fascinating, and it's based on a report in 2016 where they asked, I think it was a couple of thousand people around their test automation adoption. And this is kind of the results, right? 5% of the respondents said that they're fully automated, but 2/3 have at least 50%, if not 75%, of testing being manual. And that is, I think, very, very realistic when I compare that to the clients that I'm working with. The last couple of clients that Bidya and myself have been at are really just starting adopting this. And the question is often asked binary, do you do test automation or not? And everyone says yes, but then the coverage of it is very, very low because it's hard to maintain, because there's a lot of challenges of getting test automation right. And that's exactly what we will talk about. We will not necessarily talk to you about if you're starting a test automation initiative tomorrow and how to set it up. What we'll do is we'll tell you 7 ways of failing and then some ideas on how to avoid that failure. But there is no one correct answer for you to approach this. You contextually, it's always going to be different in the right way of approaching it. But learning from other people's experiences will allow you to kind of avoid the bumps in the road and the dead ends, because very often people have the first implementation of test automation and then they have to abandon it and start again. So let's see whether we can help you guys avoid at least that part. If you look at testing in general, I really like this view that I've come across to showcase what the different view of the world is. Not too long ago, we would have considered testing as being this test phase at the end of a project, right? In the world of waterfall, we had these, some level of activities in the earlier phases, but we really had this huge testing phase to make sure that we've done everything correctly. And you can see this kind of bulb in the top diagram there. What we came to realize is that at that point it's way too late, right? Fixing defects at that point is very, very expensive. You potentially have the problem that many of the people that were originally building that stuff has already been rolled off. And how are you going to then fix it, right? It's impossible to test quality into a product. The only thing you can do is you can, at every step of the way, build quality in, and that's kind of what the bottom pipeline shows you. Right, there's this kind of cone on quality where we want to do as much of the quality assurance as early in the process as possible, and as much of this automated, obviously. There's an underlying thing here where a lot of the technical implementation will be aligned to a continuous delivery pipeline and the different quality gates. But as long as you conceptually can have this picture in your mind that we're moving from this kind of pipette mode where you have a big bulb at the end to this cone, you have the right visual in mind. And in parallel to this, there's an organizational shift from these big testing centers of excellence that look after a testing phase towards kind of a quality center that has an end-to-end accountability for quality across the whole life cycle. Yeah, that's an organizational shift that we all need to make. All right, so with that background out of the way, let's get into the 7 sins. And this is obviously a slightly biblical reference, but we will not go anywhere near the religious favor that we might get into. The first one, and I think this is the perhaps a little bit of the most surprising one, is that if you think that test automation is automating testing, you're on the wrong path, right? So test automation is unfortunately the term that we've used for these activities, but what we're really trying to do is we're trying to find a way of automatically assessing quality. And that doesn't mean that we would do the exact same testing that we would have done otherwise manually, just in an automated fashion. The picture that I've chosen for this here is a mechanical Turk. And I'm not sure how many of you are familiar with this concept, but a mechanical Turk was, it was ultimately a trickster that pretended that he had an automated machine, but there was a human in the box that ultimately represented the automation. So they would move the chess pieces on this board with some elaborate mechanism. And sometimes test automation has exactly that problem, right? That we are just replicating what a human could do, that from the outside it doesn't look any different. Think about the really bad ideas of doing record and replay that we used to do in the early days. But it goes much further, right? It goes to doing a lot of the testing through the UI. It goes to not actually thinking of automation scripts as being code that you need to modularize and make resilient to maintenance. It goes to just considering the loads on the systems, right? So consider what 100 manual testers can do in your system, right? That can 100 people touching the keyboard at any point in time. Well, with automation, you get this to 1,000, 10,000, 100,000. You get significantly higher volumes, and that has an impact to all kinds of other areas. So 3 things that I want you to think about when it comes to that. One is the performance. So as I said, the load that you will put on the systems is significantly different. Yeah, and you need to be able to deal with that. That plays then into the second point, where you are in a networked environment, right? It's very rare that you're testing just one system by itself. So if you're that system here in the middle of that little pictogram, and you had 100 users testing things, it's okay if 10% of these go out to one of the satellite systems, that there's someone sitting there manually progressing your test case. Once you start introducing automation loads, that won't be sustainable, right? You might bring down any of these satellite systems. You might overload the humans that are sitting there receiving these requests. So you really need to think of this as a network and as automated transactions that are floating through this network. And then the third one, and I'm going to talk about this a little bit more in the next sin, is then the data consumption as well. Right? In manual testing, we're doing one test script, and then we do the next, and we do the next. But test automation means at any point in time, we might run a complete suite again because we need to validate something, or we had a small deployment of something, we want to rerun our regression suite, and we can't afford for data to be burned, so that we have to recreate that or redo it. So really think about this as, and I describe this to people as 3 architectures. You have your business architecture, which is the system that you're testing. You have a delivery architecture, which is all your kind of DevOps tools, the way of standing up environments and deploying software. And then you have a quality architecture, which is all the bits and pieces that you need to assess quality. That might be your monitoring, it might be your test data creation, it will be your execution framework. So you really need to manage all those 3 architectures in parallel. So as I said, the second sin is perhaps gluttony, but in this case, it's the underestimating the data hunger. So test automation is highly dependent on you having test data available at the point of execution. There's no point that you say you have a regression suite, but once I've executed the regression suite, I've burned my test data for the regression, and now I need to wait until I can do a full data refresh before I can execute the regression again. Yeah, that's just basically, you've basically automated the manual regression suite, but you haven't created a capability that you can deploy at will. So one of the really good litmus tests for the success of test automation is to ask yourself, once I've executed this suite, can I execute it again? Can I execute my my test automation in parallel to manual execution, so that I'm not hurting anyone while I'm doing this? And there are a bunch of practices that help you with this. So if you think about this slide, that is a nice little framework. There are 6 practices that we think are important. So the most crude one is obviously data refresh, which you can pull from a production system or any kind of other data source. But then you need to have a couple of other practices to support this, because if you just take in production data, very often it will be too big, and there will be stuff in there that you don't necessarily want your testers to have access to. So you need an automated way of doing data masking and obfuscation, so that you don't get production personal data into your test systems. You might have to do some data subsetting to create a smaller slice, or perhaps even create virtual data sources. You need to be able to integrate the data automatically. So it might be the provisioning of picking up a specific test case. I was working with a government organization that had pretty complicated setup, and we might have to find I'm from Germany, so you might have to find a German immigrant with 3 kids who are divorced, right? And that's not necessarily something that exists in your normal test data set, but you might be able to find it in production. So how can you then find that, identify it, bring it in, and then leverage the kind of data masking bit to make sure that it's not identifying Mirco Hering as the guy. And that needs to be as automated as the execution framework. Sometimes all that fails and you need to actually generate data. Ideally, you do this through the actual business system. So you create a new account or a new customer, but that obviously needs to be automated as well. And that sometimes means you have to pretty much create a shadow system that creates something that looks very similar to what the business system would create. And then last but not least, you need to be able to identify that the correct data sets to use. This by itself is a whole practice, and too often people just have a point in their test automation framework that says test data, right? But you really need to think about this in an architectural sense, which then leads me to our sin 3, which is not embedding test automation into your continuous delivery pipeline. Yeah. If you have test automation just as another silo, we haven't seen that being successful in most of the cases. There are some rare cases where that might work, but usually it doesn't. And this is for multiple reasons. Like everything I've described in the first 2 sins tells you that that you really need to be aware of how test automation fits in the other architectures and into your delivery mechanism. So if you are sitting in an ivory tower somewhere creating a test automation framework by itself, you're extremely limited. You need to make sure that you are very close to the developers. You might need the developers to build your hooks into the system. You might have to ask the developers around the data structure so that you can actually synthesize the right data for your test cases. You also need to think about performance, right? I've been in places where they created a regression suite and they were really happy after the first 100 test scripts were automated. Everyone was celebrating. The first 100 scripts took 2 hours. And then we look at, so what would it require for us to just have the kind of core processes being regression tested? And there was a couple of thousand scripts. And so when we then extrapolated and said, how long would it take us to execute that? It was like 3 days. Right? Absolutely useless in the context of a continuous delivery pipeline. And that's because it ran outside of that process. If you force yourself into the same process where your deployment is not complete until you've run the regression suite, then you will keep thinking about the way to parallelize this, either just from an execution. Sometimes if you're using high-level test automation tools, your licensing or your desktop setup doesn't allow you to run more than a couple of threads in parallel, so you have to create multiple instances of that. Sometimes the environment is your limitation, so if you're in the cloud, you might spin up a couple of environments and run subsets of this test in each of the environments. All these are valid options, but the answer really is that you need to build it into your continuous delivery pipeline. And as I said before, test automation is not just functional test automation. It is everything that has to do with quality. So you can see here, and this is kind of an abstraction from Jenkins here, it really starts from static code analysis all the way to performance and then UAT and operational readiness on the right. The goal or the principle here is that speed is more important to us than accuracy, and that for most testers is like, oh my God, you can't say that, it's heresy. But the reality is, if the performance degrades in a lower level environment that is not at production scale, we can be reasonably sure that our performance will also degrade in our low test environment. If we have security violations in our dev environment, we do not have to wait for our security testing at the end in a hardened environment. Yeah, so we might only find 80% of the problems, but we rather find those 80% of the problems earlier on and not wait until the very end. Because in the speed that we are operating, we don't want this bulb at the end, if you remember the diagram that I showed you a little bit earlier. Continuous delivery pipelines are a forcing function. They are forcing you into some good behaviors. And I think that's something that we want to leverage for our culture and our process. So those are the first 3. I'll hand over to Bidya to talk to you about the next 4.
Thanks, Mirco. I think you set up the context really well. And if I can move it to the next slide, which is For people who are on the call, if they know about Dante's work of Divine Comedy, right? That lists basically the 7 sins that human beings do and how they get paid for it. I think this discussion or webinar basically sets those sins in test automation frameworks, test automation approach, and how do we avoid it. And I think Mirco said the context very well. And so I'll continue the rest of the sins, and I'll continue from sin number 4. Although I feel that in the enterprises that I have worked with, this is the number 1 sin that they commit, which is the Chinese whisper. I call it the Chinese whisper because this is based on whatever people basically interpret. The test automation guy, he's a guy who's very, very down the line, very down in the chain. He basically hears it from different people, what he has to do, what he has to come up with, and he designs a script or designs a framework which has nothing to do with quality. It basically automates a test case, as Mirco was pointing out in the first sin. It basically tells that the 100 steps that a person was doing it manually can be done automatically right now, either through different ways of orchestration, probably through Jenkins, or probably through a batch script, or probably through a command line. But ultimately, it's automating the manual steps. And I think that's the number 1 sin that most of the enterprises do, which is have a dedicated test automation team which sits well outside the fence. The BAs give the requirements, get the requirements from the business. They give the requirements to the build team. The build team starts designing it. The testers get a product, and then the testers write the manual steps, manual verification steps in Excel sheets or whatever, and then this is chucked over the fence to a poor automation guy who has to come up with an automated script. And in most cases, it is a tactical way of a knee-jerk reaction kind of thing, in which we say, okay, how do I save cost? Now let's automate it and run this test repeatedly. I think that's the number 1 sin. Now, what I'm showing right now is basically how to avoid it. And this slide basically tells you a modern enterprise how it should work. Again, there is no silver bullet to any of the problems, but I'm just giving a context to it. That if we have got an approach in which the test engineer, I call them test engineer. I somehow don't like the concept of manual engineer versus automated engineer, because an engineer is a person who can basically do the quality check, right? So if he is embedded within the sprint teams, and if he's looking at the requirements right at the front, basically along with the BAs, he's one of the 3 amigos who actually look into the create the acceptance criteria of the requirements. I think that's an approach which basically will give an enterprise value for its money, for its quality, for testing the quality of the requirements. Now, this is a continuous design, continuous delivery pipeline. As you can see that we have got backlog, which are epics, we have got stories, and we have got tasks. Now, as you can see in each of these, the most important part is that the build team consists of the test engineers and the build engineers. And the test engineers, build engineers together, they say that, yes, this is my scope of the story. This is how my acceptance criteria is. This is what I'm going to write a set of evaluation criteria, which will basically measure the success of the requirements. Now, this is sin number 5, which is the seeing is believing test. Now, we spoke about the team structure, as in we definitely need to have test engineers, quality engineers built within the Scrum teams and not as a part of a different team. But now I'll talk about another sin which is commonly seen, which is the seeing is believing test. Now, what is this? This is basically our need to see the automated test run on a screen, right? I think Mirco touched it when he said that the UI based test, and I call it the seeing is believing test, because whenever I talk with the senior management of the enterprises, they tell me, okay, show me a demo of your test. And if the demo does not open up many screens, and if it does not do a lot of clicks and a lot of actions on the screen, they say the automation is useless, right? I think that's the mentality which needs to change. That's one of the sins that I'm highlighting here. That you must understand that seeing is believing. That's true, but you also know that believing is also seeing. So there are tests which you need to run, which run in the background. There are tests which are, for example, the ping test that you do before deployment, after deployment on an environment. For example, the integration checks that you do to make sure that the environment is stable even before the functional smoke or functional regression runs. Those kind of tests are most important in the context of this entire test automation. Rather than having a UI based test, your test must have a huge percentage, and by huge percentage I mean at least 70 to 80% of your test should be covering through your service layer, the API layer. Now, that's not true as in the present state of the state that I see in most of the enterprises, but that's where we need to be. And basically what it does is in each of the sprint, if we depend on the UI test to start writing our test automation, then we will never be able to write automation code within the sprint. So normal practice that I have seen for agile teams is that the automation team runs one sprint behind. I mean, that's a very usual practice you would have seen in most of the agile teams. There's a specific automation team. That automation team runs one sprint behind because they say that, okay, the code has to be stable first and then only we need to automate. Now, whenever I hear those responses, I just remind myself that you can write test without having any UI in place. You can write test against a interface spec. You can write test against a data dictionary. You can write test against a contract between two services. Those tests do not require any presentation layer, any UI. And thereby, that's the only way you shift left your quality matrix, you shift left your test automation, you shift left your testing practice. Now, this is one of the interesting sins that I've seen, and I think you might have seen as well, which is the pigeon coop test. Now, the reason I call it as a pigeon coop test is because I see hundreds and hundreds of tests doing the same thing. So basically, there will be there's a set of regression test suite which goes through the same code coverage, same code branches each and every time. The only reason they exist is because they look good on paper, right? You would say that how big is your regression size, and you would say that, oh, my regression size is 100 tests. Does 100 of those tests each make sense, or each go through a unique code path? That's the kind of sin that we make commonly in designing our framework. And this is a quote from Trey Smith, who says that if this doesn't make an impact, then its absence doesn't make a difference, right? So out of those 100 tests, you would have seen that normally out of those 100 automated tests, if even 20% fail, we still say that yes, regression passed, but those scripts failed, right? The reason we are still going ahead and saying that the regression passed is because we think those 20% of the test case which failed did not make an impact. To which my point is that we should not have those 20% of test cases at the first place. Your tests should be unique. Your tests should be very, very targeted. It should be so the value of creating each test should be defined as a testing practice, and have been doing test practice for quite some time now. And what I what I have seen is that over the years we have forgotten the value of a test case. So we write test case left and right. Like if you ask a developer, he goes through a lot of checks before he writes in or commits one piece of code. So he does a static code analysis. He might run a JUnit. He might do a unit test. But what we test as a testing practice do is write scores and hundreds of test cases without even bothering to see the efficacy of each of the tests. I think that's the sin that we make every day. For instance, in one of my past projects, I saw that for a single scenario, which could have been easily covered using permutations of data, they wrote 120 scripts, and they were trying to automate that. And they had actually budgeted 3 people doing 4 weeks of effort to automate that piece. And that's the kind of sin that we and devil lies in the detail, right? And when you dive deep, when you deep dive in that, you understand that most of those 120 scenario test cases or scripts could be covered using one scenario having intelligent permutation aspect of test data. Now this graph basically shows that your test design should basically have 2 parts, and both of the parts basically address the same thing, which is how do you cover the risk basically. So your risk coverage should be increased by building the proper test design methodology. So normally what we have seen is that 80-20 rule, which is 80% of your application can be traversed through 20% of the scripts, right? Now those 20% scripts or those 20% of the scenarios is what you need to design and what you need to identify as a first place, because those 20% of the scenarios are the crux of your application. Now coming to the 7th sin, which is the Lamborghini amidst the lamb. Now, what you see right now is a state of the art machine, but it's stuck within the lambs, right? So now the design of and this is the sin. So the design of the framework, design of the tools, design of the test automation basically needs to take care of the ecosystem that it operates in. So if you see, I have put a placeholder here, which basically shows that there are 2 types of systems in any enterprise that you work for. There are systems of engagement, and then there's systems of record. Now, systems of engagement are nothing but where you collect all the information through outside sources or inside sources. You just those are your portals which basically collects the information. Now, anyone who has done test automation would know that most systems of engagement can be automated using any open source systems. There are hundreds of open source tools which can basically target each of those systems of engagement, whether it is portals, whether it's websites, whether it's content management systems, whether it's social Facebook or social media, right? But then there is another set of systems which are systems of record, which are basically the mainframes, the legacy systems, the app service, the ESBs, etc., which basically cannot be done, or even if they are very limited to the open source tools because they don't expose their properties, they don't expose their objects, etc. Now, many times the sin that I've seen is that designing a test automation framework which only caters to only half of the problem. So I have seen people designing framework which only addresses the systems of engagement, completely forgetting that there is a systems of record which basically feeds into systems of engagement. And therefore, the design of your test automation framework needs to be an overarching solution which can connect all these discrete systems. So it has to basically talk to the systems of engagement. It has to also be able to talk to the systems of record, and therefore a test automation architect or a test automation engineer who's working on it needs to have a holistic view of the technology ecosystem of that particular problem. And this is what I said in each of my assessment, and I do this assessment at a lot of clients' places. And this is what I do basically, which is study the entire topology of the client ecosystem and then provide a solution to that, rather than providing a solution which basically can fit them in the short term, but in the long term, when they need to migrate the legacy systems, scripts might fail, and then the client has to again reinvest in creating some other new framework. I think
that's an interesting segue. I mean, we're getting to the end of the sins, but there's this underlying theme of you do have to have a test automation framework.
Yeah.
It's not I have SAP, so I'm using an SAP test automation tool, and I'm using Facebook, so I use a Facebook test automation tool. You really have to think about this as an end-to-end solution. And this is kind of where my earlier comment on the architecture comes in, because if you're building all these individual solutions, it's really difficult to stick them together at the end. I've seen some pretty Rube Goldberg solutions where there's some Jenkins on top, and then we put some QPT on top, and we put some Selenium on top of everything, and it's not gonna work. Right? To Bidya's point before, have a look across the ecosystem, understand all the components that are in there, and then take all the other 6 sins into consideration, and build a framework that is sustainable. That little bit of extra work up front will stand you well as you're progressing.
Yeah. And I think what I've not added, but that's an interesting segue, is that that we immediately jump into tools, right? I keep talking to a lot of customers, and what the problem that they come to me is, how do I solve it with a new tool? And I keep telling them that it's not a tool problem that you are trying to address. It's a approach problem that you are trying to. How do I approach it, rather than how do I solutionize with a new shiny new tool, right?
Yeah.
And I think you would have also experienced that same thing in all your discussions.
Yeah, people want to buy the silver bullet for test automation, right? And
yeah.
That's why I find it always interesting when they say, what is the best tool for? I'm like, what? I don't know your context.
Yeah.
Like, there's no one tool for one specific technology.
Yeah. So just to give a context, right? I was working with this client a couple of weeks back, and they had this few people flown into the office, and then they said to me that we are a very high matured agile team, and I said, all right, and we don't want you to tell us how to test. What we want is you give me a tool which will help my developers test. And I was like, okay, all right, I will not tell you the process of how do I do agile testing, but just tell me who creates the acceptance criteria for you. And their answer was, oh, our BAs do it. And my question was, okay, and what's your test team doing then? And he was like, no, we don't involve them in the acceptance criteria. And then I said, mate, you do not have a tool problem, you have a approach problem. You should include them in your acceptance criteria writing. So
yeah, no, I completely agree. Now we do have 20 minutes for questions. I saw a couple of them coming through, but I don't know how to scroll through them, so I'll hand over to Emma to actually tell us the questions, given that we can't find them.
Hi guys, thank you very much for a fantastic presentation. So one of the first questions that we have here is, how can we find the best tool for automation of a particular application?
Fantastic. That's like nearly on cue. I mean, I will give you my perspective. I mean, there's obviously much of a saying tooling is not going to find you the answer. There are obviously worse and better tools. My view is that once you understand the approach that you're taking and the technologies that you're dealing with, then you can start assessing how you will use a tool, right? And the reason I say that is, it's do you expect your developers to build test scripts that you can then use across different environments? Do you have a dedicated test engineer in your agile team that will kind of pair with the developer and build it up in parallel? How much of this is being executed from somewhere external? All of these factors play a role, and obviously the technology as well. So there are some limitations, as Bidya mentioned, to some of the COTS products, for example. I have 3 key guidance that I use for all tools, test automation or not. One is you need to be able to execute them from external. They can't consider themselves to be masters. That means you need to have APIs or CLIs or something that you can execute and orchestrate. You need to be able to feed and extract data. So obviously in our case, we will deal with test data that you want to feed from potentially external source, but you also want to be able to get the results back out and being able to publish that in a report or something. And then the third one is that the licensing should be supportive of your model. So the example that I gave earlier about that regression suite that ran for a few hours and would have taken 3 days, the reason that we couldn't actually parallelly execute it is that the license cost was so high that we couldn't afford more than 3 instances. Now, if you know from the get-go that your application is relatively slow and it will require a high level of parallel execution, then the license model needs to be very highly considered, because otherwise you might rank up a lot of cost. But Bidya, perhaps share a couple of your thoughts as well on how to choose the tool.
I think, Mirco, there's absolutely no way you can say that without getting into the context of the problem. So I was just speaking to someone, and they use the frameworks called as Chai, Mocha, and Jasmine. Now, to any common man, they would seem like flavors of tea, right? And flavors of yeah. But my point is that each day there are new tools coming into the market for each and every problems that we are trying to solve. There are hundreds and hundreds of tools available. Some things, some do better, some cost more, some cost less, some are open source. But I think those 3 criteria that you said are the bottom line, are the thumb rules basically for selecting any tool. But there's another, the 4th one, which are definitely I think you touched it based on the license cost. But I think the 4th one, which I would say, which is a sub category, you can say, which is basically the situation that client is in, right? I mean, a lot of times I have been to a client place in which they have already purchased a huge loads and loads of HP QTP, and they are sitting on it, and then they are asking me, what should I do with it now that I have purchased it, right? Now, so those kind of context also comes into play whenever you are selecting a tool, which is the client's appetite, the client's advisory, who has advised him to go ahead and buy such tools. But for anyone to recommend a tool, he has, as I was mentioning, the 7th sin, he has to understand the context of the in which the tool is going to be used.
There's a good point in there, just to highlight. I think you said it between the lines, but in the client context, it's also what the client actually has experience with. Yeah. But so they have lots of QDP experience, and then they can probably solve a lot of problems with their tool rather than just throwing it out and putting something new in. Absolutely. And very often the programming language makes a difference as well, right? Are there more Java programmers or C programmers, yeah, or none of that at all? So that you need to consider that as well.
Fantastic. We also have a question asking for you guys to give your thoughts on AI in automation.
Oh, exciting. I'll have a crack first, and then let Bidya mention it. To be honest, in the testing realm, I do not have a lot of experience. I do, however, I have a master's degree in artificial intelligence, so I'm super excited to see this now becoming more and more prevalent. I'm a little bit skeptical because a lot of the stuff that is being sold to you as AI is really more rules-based. One of the things that Bidya mentioned earlier is the kind of the clever analysis of what test data permutations to use. I think that's actually something that we, even in absence of AI, have underutilized for us to understand, and how we can stretch the test canvas with cleverly identifying the right test cases and the right test data behind it. And I think that's potentially something where a lot of the machine learning stuff will come in handy. I also see an overlap with some of the operations stuff that I usually work with, where you can use mechanisms of understanding traffic in production to identify the highest impact modules or process flows or elements of a process, and then leverage that, so the learning from that to determine what testing you need to do. They're probably still on the lower maturity on the AI curve, but I think they're somewhere in that gray area of it. Not sure how much you've seen, but yeah.
Yeah, so I think there are some cases where they have implemented machine learning, for example, in defect analysis, in making sure that the kind of defects that come through, you read through that, your machine learns about it, and then tries to regress those areas by running them, by connecting them to a Jenkins job. Now, those cases have been there, but you're correct, Mirco, that maturity is still questionable. Maturity is still at a very nascent stage. But I think this is a this is a very fascinating time to be in this curve, right? Because you can only go up from here. I mean, whether you call NLP, whether you call machine learning, whether you call AI, I think it has got a lot of usage in test automation. When I say test automation, again, the definition, what I want to bring in is basically, how do I make sure that my test automatically run, right? I mean, rather than me instructing someone to, can you run this at 3 p.m. in the 3 a.m. in the night? Rather than that, how my AI basically says that, okay, since this defect came in and this defect is more towards integration, how do I make sure that I run our integrated test based on the outbound services?
Okay, fantastic. And then our next question is about developers writing end-to-end testing. What is your views about developers writing end-to-end testing and automation engineers helping to create a framework in DSF?
Emma, if I got the question correct, is it about end-to-end testing?
It's what is your view about developers writing end-to-end testing?
So whether the developers should write the end-to-end testing as part of the development process versus test automation engineers just providing the framework, I guess.
That's an interesting question, and I can safely say that I am working currently on one of those contexts in which the client basically wants to replace the entire testing faculty, and they want to retain the developers who can write their own test. Now, historically, the reason why there's a specific practice of test setup was because the developers did not test their code. Now, what the industry standard says is that for every line of code that a developer writes, he has to write 3 lines of test that basically test the code, which is, again, given the delivery pressures and the timelines that we are operating under, never happens. And therefore, there's a layer of testing that we do. But coming back, I think the practices like the TDDs and the ATDs, which is acceptance-driven development and the test-driven development, even behavior-driven development, do tell us that you write your scenarios or write your test cases first, and then you basically go ahead and start coding it. Now, who does it? That's I think is the least important question. How they do it, that's the most important question. I think if I talk about some teams who are on a very high agile maturity journey, they are cross-functional, they are cross-divisional, they are basically what I call as the one engineer, basically, in which an engineer in that Scrum team knows exactly what he needs to do in the morning. So a day in life of that engineer is not a day in life of a developer or a day in life of a tester, rather it's a day in the life of an engineer. He knows that today I have to write my code or today I have to test my code. I think that maturity is level 5 on a scale of 1 to 5. I think that's a level 5. But Having said that, that is absolutely the acceptance criteria, which basically validates the requirements, needs to be written with the help of the three amigos, which is the BA, the test, and the developers.
I just want to make one additional comment there, and kind of looking a little bit ahead in the other questions. I think the test script at some stage needs to come out of the Agile team, just as Bidya described. I think there's a need for someone to channel that and orchestrate that, and so that might be your, we call them test automation architects, you might call them test automation engineers, whatever it is, but there's someone who sits slightly outside to make sure that the 10 different Agile teams, as they're creating their own script today, they're working towards or within a common framework, and that you can orchestrate across them.
That's the governance.
Yeah, and this leads, I think there's another question around how do we transition from our manual testers to test automation engineers, and I think this is where that very often falls apart, because manual testers have been really thinking about the execution of individual script. They never had to think about the orchestration from a technical perspective, and that's a pretty steep learning curve for our developers. Always think about that, because they always have to worry about integration, they have to worry about interfaces, they have to worry about common modules, all those kind of things that will again play a role in your test automation. And there are some vendors out there that tell you that if you use their magical test tool, that any manual tester can become a test automation engineer. I beg to differ there on that end.
Okay, fantastic. We also have a question that we regularly hear coming up here at Blaze Meter. Somebody said that they have similar issues in their organization, and how can they convince managers not to convert manual tests to automation, but rather to target automation tests in a different way? Basically, how can they convince the managers to shift left?
Yeah, I mean, this is now we're getting to the crux of it, which, you know, up to now we spoke a lot about the technologies and the approaches to this, but yes, there's a significant change effort there in regards to supporting or convincing leadership or management to actually go down this path. I think I struggled with that for a long time until I could come up with the idea of those kind of three architectures, where I explained to people, you know, you would not do what you're doing in testing for your business applications. You wouldn't just install 3 different tools and hope they work together. You wouldn't just create customers in 3 different systems and hope that they are the same. And that is basically what you're saying when you're saying, oh, we're just going to manually execute some stuff, and then we're going to automate that manual script in an automated fashion. You don't do that when you're doing an implementation of a business system. You don't do that when you're talking about a DevOps pipeline, and you certainly shouldn't do that for test automation. If you really need more evidence, I think there's sufficient reference material out there that tells you where test automation fails. So the report that I referenced earlier is quite useful as well. And then it's a matter of showing them. Right, so read it at the client that I mentioned earlier about this 2 hours of regression suite. We had manual execution on one case where we basically did a time of motion study, someone sitting behind the tester measuring that. We automated that as is into one tool, and then we had someone actually restructure that into a modular structure and execute that through. In this case, we use Jenkins as a scheduler. And even from a timing perspective, that wasn't necessarily that different. But here comes the kicker. Now we changed something, right? And now we said, okay, let's see how long it takes for the manual tester for the middle one and the automation, the proper automation. And the proper automation was like minuscule, because all we had to do is we had to change one component while everyone else needed to do the whole end-to-end again. The manual tester had to rewrite the test script. The end-to-end automation script had to basically look through the whole thing and figure out what had to change. And our componentized things really just had to change the business rule. So a very, very powerful way of describing this.
Yeah, I think Mirco, just another point to that is the culture, right? I mean, we addressed that in one of the points earlier, is that you can make as much a strategy, but culture will eat it, eat strategy for breakfast, right? But I think the core message that that needs to be relayed for any modern quality engineering practice is that mindset needs to shift. I still have got Scrum teams or Scrum leaders in the implementations that I have seen, is that they think test automation as a practice which comes at a later point in time. Comes afterwards. So they say that, okay, let me build, let me test, and then I'll think about automating it, right? Now that mindset has to change, and that mindset can only change by implementing, and demonstrating, as you correctly mentioned, that we need to showcase, we need to keep on showcasing the benefits of automating right there, right in the sprint itself. I think if your strategy, if your tools, if your process are aligned and you are able to demonstrate that value, I think slowly the culture would shift towards a more modern quality engineering based practices.
And I think that's a good thought there, right? This kind of +1 sprint that people very often do. They do all the testing in one sprint, and then they do the automation in the next sprint. As soon as you do that, it's really hard to get the benefits, because it's an extra cost. If you're embedding it directly into your sprint, then you can actually get the benefits of faster execution, because it might not work the first time around, right? The developers might not be perfect. That means you're already getting the benefit within the sprint because you've executed the same test a couple of times. Absolutely. If you're doing it in sprint +1, then it immediately becomes just an insurance policy and becomes a pretty expensive exercise.
Yes.
Fantastic, guys. We have time for one last question. This is actually a question about legacy frameworks. So one of our registrants was asked, these are great guidelines for designing new frameworks, but how can we overcome these things with existing frameworks which are already in place?
Okay, so in the context of existing test automation frameworks, so I first thought we were talking about the kind of a legacy application. That is a brilliant question that I mean, you can't throw it out, right? So I can't count how many times I've gone into an organization and they had an existing test automation framework. We identify all the weaknesses, and then ultimately gets thrown out and we start again. And guess what happens then? The same mistakes will be made with a new framework, because it's usually not necessarily the technology's fault, right? It's in the implementation and the details. Yep. What we've done in a couple of places is really analyze the end-to-end lifecycle, as Bidya mentioned it. Where are we using it? Where it's being developed? And then figuring out where the weaknesses are. Like where is this? Where's the additional cost? Where does it take too long? Where is it too far away? Where we don't have the 3 amigos? Where is this broken up? And then fix the process problems. And through fixing the process problems, the framework will evolve in the right direction. In most cases, I mean, there are some fundamentally broken frameworks, but if you assume that the framework is not completely broken, fixing the process will fix the framework over time.
Absolutely, and I think it goes back to saying that the same question which was raised, right? The tools question. I would say that if you have implementation already in place and you still think that there are sins that you have made and you want to rectify them, I would say that go for the sin which is making the biggest impact in your process pipeline. So to answer that, you basically need to question yourself: why am I doing what I'm doing? So whether you are writing your configurations in an Excel file, whether you are maintaining a data sheet in a CSV file, whether you are calling COM components through the script, I mean, all of these decisions are basically tied to a reason why you are doing it. And once you start asking that question and you don't get the logic of or if you don't see that optimized value out of it, then try to change that part of the process. Absolutely, you cannot scrap it the entirety. Though I have seen in places wherein they have gone ahead and they have removed the entire automation framework and they have started new. But for getting the biggest bang for your buck, just identify the core problem. What's getting you what's the process that's slowing you down to achieve what you want to achieve, and then start by fixing that problem first.
Thank you, Bidya. Thank you guys for staying with us. I know we're at the hour and we're actually getting kicked out of our room as well. Thanks for staying with us. I hope you took a few things away. All feedback is appreciated. Thanks, Emma, for hosting us and for Place Media to invite us to share some of our lessons.
Thanks, Emma. Thanks,
and thank you so much. Thank you for your fantastic presentation, for both of you. This was really great. I can see already in the comments that a lot of our users found it really useful. And as a reminder to everyone, we will send over the recording in the next day. Thank you very much, guys. Have a great day.
Thanks for the questions, guys. And any feedback is appreciated. Thanks.
Bye.
Bye.
Bye.